Hi, welcome to 5.3 on energy. Today we're talking about mechanical, potential, and kinetic energy. And we're going to be looking at their charts, graphs, equations, and calculations. So what is energy? Well, the definition of energy is the capacity for doing work or producing heat. And the law of conservation of energy says that energy cannot be created or destroyed. It can only be transformed from one form to another. Today we're going to look at the two types of mechanical energy, that being potential and kinetic. So potential energy is energy associated with an object's height or position above its normal position. And we're going to designate that as Eg, energy due to gravity, or sometimes called simply Pe, or potential energy when looking at mechanical. When this pendulum is raised to its highest position from position D to C, it has gained energy because I've done work on it. When it's raised all the way to position A, its highest point, all the energy it has is going to be potential. Kinetic energy is the energy associated with an object's motion. It depends on the mass and the velocity of the object. When the pendulum moves from position A to B to C, it gains kinetic energy, designated as Ek. When it reaches position D, it is moving at its fastest, and it will be all kinetic energy. And again, remember, we're operating in a perfect physics world with no friction. So energy charts, pie charts are a really good way to view the amount of energy present. If all of the energy at position A is potential energy, because it's at its highest point, and all of the energy at position D is kinetic energy because it's moving its fastest, we would designate that by a simple circle completely filled in with Eg at position A and Ek at position D. Now, in between those two, as it swings to its lowest position, moving faster and faster, all of the energy that was Eg is going to be converted into Ek. But at positions B and C, it's going to be a mix of Eg and Ek, but not exactly half and half because it's not halfway between them. So we might say there is more Eg at B than there is at C, and more Ek at C than there is at B. Although pie charts are good, most of the time we'll actually use a bar graph, as if all of the energy is represented by 4 blocks of bar graph energy. So at position A, we would have 4 blocks of Eg. At position B, we might have 3 Eg and 1 Ek. At position C, we would have 1 Eg and 3 Ek, because you can't have part of a block. Think about taking Legos apart. And at position D, we would have all Ek. From a chart to a graph to an equation. If a ball is bounced, what would its pie chart look like, bar graph, and equation? So this is the situation we have. The ball has been bounced. At position A, it's on its way up. Position B is halfway up, C is at its highest point, D is halfway down, and E is right there before it hits the ground. So position A would be all Ek. B would be half and half, C would be all Eg, D would be half and half, and E would be all Ek again. Those are the pie charts. The bar graph would be similar. 4 blocks of Ek, half and half, 4 Eg, half and half, and 4 Ek again. The energy equation simply gives the type of energy at location. But remember, energy is not created or destroyed. So absolutely everything we have at position A, we have to have at position E. So the energy equation would look like this and would be read. The Ek at A is equal to the Ek at B plus the Eg at B is equal to the Eg at C, is equal to the Ek at D plus the Eg at D is equal to the Ek at E. Essentially saying 4 is equal to 2 plus 2 is equal to 4 is equal to 2 plus 2 is equal to 4. The other mechanical energies that you will come in contact with during today's assignment and during this lesson are elastic, EEL, which is spring energy, and ETH, thermal or friction. Remember that sometimes objects do slow down and we're not playing in a perfect physics world. So only EG and EK can actually be calculated, but EEL and ETH can be known. To calculate the EG at A, we must know the mass, gravity, and height of the ball. In order to calculate the EK at position D, we would have to know the mass and velocity of the ball. But knowing the total EK or EG at any position allows us to calculate information for other locations. Let's look at your formula sheet. Potential energy is EG or MAY. EG is the potential energy measured in joules, M is the mass in kilograms, G is gravity in meters per second, and Y is the height in meters. But remember, we don't always just have to find EG. Sometimes we have to find the mass and sometimes we have to find the height. So M is EG divided by A divided by Y, and Y is EG divided by M divided by A. This should be on your formula sheet. Also on your formula sheet, you want to add the formula for kinetic energy. The formula for kinetic energy is EK is equal to 1/2 mv squared. EK is the kinetic energy measured in joules, M is the mass in kilograms, V is velocity in meters per second. Note that V squared simply means velocity times velocity. And sometimes we have to find mass, which is 2ek divided by v squared, and sometimes we have to find velocity, which is the square root of 2ek divided by m. This should also be added to your formula sheet. Let's look at that pendulum problem as an example. In the pendulum example, if A is 2 meters above the lowest position D and the mass of the bob would be 5 kilograms. How fast is the bob moving at position D would be our question. We know that the EG at A has to equal the EK at D. We also know that EG is mg or AY and position A, and D is 1/2 mv squared or the EK at D. Plugging in all the values that we do know, we can solve for the velocity to be 6.26 meters per second at position D. Thanks for watching.